This is our last lesson of the entire course, and hopefully it's a lesson that as I'm going through and talking about it, it's using a lot of skills that you've already had. So we're not finishing with something really crazy difficult. So the last lesson, the section is 8.6, and the focus is on solving what's called a rational equation. So a rational equation is any equation, obviously it has an equal sign, that has at least one side being a fraction. That's what it means by rational expression. So you see something like x over 2 equals x plus 3 over 7. That would be an example of a rational expression. The way we solve rational equations is we cross multiply. So this is something that I feel like you do a lot, even with like basic equations in algebra 1 and geometry. So cross multiply means that you're going to go across this way and multiply and set it equal to going across this way and multiplying it. We call it solving a proportion. That's what cross multiplying is. And then finally, the last piece may be something a little new. We've talked on and off throughout this year about extraneous solutions. Extraneous solutions being that you do everything right and something still doesn't work out with the answer that you get. There's not a lot with extraneous solutions with these. The only thing you have to check when you're all done is you want to make sure that any number you get for a solution doesn't make the denominator 0 because you can't divide by 0. It's a really quick check, and I'll show you that as we go through. So this video is going to be focusing on linear rational equations, and then I'll make my very last video on quadratic rational equations. And these are coming straight from Delta Math, so you get to see exactly what they are expecting you to have. So when you cross multiply, you're going to multiply across the equal sign diagonally. You do have to distribute a ton with these, lots and lots of distributing. So when I multiply diagonally, it doesn't matter which one you do first. I'm going to go this way. I have 8 times x and 8 times negative 3. And then when I multiply diagonally the other way, I'm going to get 3 times x and 3 times negative 8. So then I'm left with something linear. All of these are going to be linear. We're going to deal with the ones that have x squareds in it, the quadratic ones, in the next video. So I'm going to add 24 to both sides. That actually cancels it. So I get 8x equals 3x. I'm going to subtract 3x. I get 5x equals 0. And so x equals 0. And you might look at this and say, is that okay? Can I get 0 as an answer? As long as this answer, when I plug it back in, doesn't give me a 0 in the denominator, it's a valid answer. So if I put, there's no x here, there's no x here, I'm never going to end up with a 0 denominator. You can check your work, though. You can check your work by plugging x into where it is on both sides and making sure that both sides are equal. So you get one answer. All of the linear ones, you're going to get a single answer. So let me do this one. You're going to distribute. So when I distribute, I get 6 times 3x is 18x, plus 6 times 9 is 54. Going across the other way, 5 times 4x and 5 times 2. Just make sure you remember to distribute. So you want to get all your numbers on one side and all your x's on the other. So we have 18x plus 44 equals 20x. So now I'm going to subtract 18x, subtract 18x. I get 44 equals 2x, and divide by 2. Again, to check the validity of your answer, you can take the 22 and plug it back into each side of the equation, make sure both sides are true. You also want to make sure if there's any x's in the denominator that you'll never get a 0 in the denominator. This one, again, only has numbers in the denominator, so there's no issue there. 2 more. Distribute across the diagonal, distribute across the diagonal. So on the left, I'm going to get 8x minus 24. On the right, I'm going to get 25x plus 10. I'm going to get all my numbers on one side. And you can do this a little faster. And if some people like to do all the moving around at once, that's perfectly fine. All your x's on the other. So we get negative 17x equals 34. Divide by negative 17. We get negative 2. Make sure that when you put negative 2, it makes both sides equal. And you also want to make sure that if you put negative 2 here or if you put negative 2 here, you would never end up with a denominator that equals 0. And again, you don't. So it's a very quick check when I talk about extraneous. And then finally, the last one, distribute across each diagonal. So 9x plus 18 when I go that way. And then going the other diagonal, 35x plus 49. Again, it does not matter which one you put on each side. So I'm going to subtract 18. So I have 9x equals 35x plus 31. I'm going to subtract 35. Subtract 35. So I get negative 26x equals 31. You get a weird answer here. I mean, I just want to double check that I did everything right. I think I did. So 9x plus 18, 35x plus 49, subtract 18, you get 31, subtract 35x. I always like to double check if I get a weird answer that it's right. Doesn't mean it's wrong, just kind of a strange one. Negative 26 and divide, and that will not reduce. So I'm actually going to leave my answer, rather than write it as a decimal, I'm just going to leave my answer as negative 31 over 26. And again, I have no x's in the denominator, so nothing to worry about. It's extraneous. So that's your first type of problem. You can get positive answers, negative answers, fraction answers, zero answers, but you are going to only get one answer for these.